Morning. It's time to start section 7.2, ionic bonds and ionic compounds. So, where do we get salt from? It's actually mined, and it's actually all salt is sea salt, quite honestly. Kosher salt has been blessed by a rabbi. There's various things that make salts different, but all salt tastes the same, and all salt comes from the sea, which is kind of interesting. Even if it's underground, it was an underground lake or saltwater sea, and the water evaporates, leaving behind the salt. So, formation of ionic compounds. How do we make a compound, and what is the electrical charge of that compound? So, when we make sodium chloride, which is table salt, it is an ionic compound that has sodium cations and chloride anions. And since sodium has a +1 charge and chloride has a -1 charge, it comes out to a 0 charge overall. So an ionic compound is a compound composed of cations and anions. Although they are composed of ions, they are electrically neutral, which means the total positive charge equals the total negative charge, which makes sense. Anions and cations have opposite charges, and so they attract each other just like two ends of a magnet attract each other. And that's what holds it together, is those electrostatic interactions, and that's called an ionic bond. So, when a chlorine atom and a sodium ion react to form a compound, sodium loses one electron or transfers one of its only valence electrons to the chlorine atom, creating chlorine into chloride and sodium into sodium. The names don't change for sodium, and so they both have a noble gas configuration, and the charge differences hold them together. Aluminum metal can react with bromine, and it's a very violent reaction. You can see in the picture there's actual sparks, and it's burning, it looks like. And that's because that energy transfer of sodium to chlorine, from aluminum to bromine, is very exothermic, and we get 3 bromine atoms for every 1 aluminum. So it doesn't have to be a 1-to-1 relationship. I think that's going to be the first thing I need in your notes, and I'm not going to say that word, so you can't just search for it. First one is going to be the formula for aluminum bromide. So make sure you put that in your notes and maybe even highlight it, so it'll be easy to find for me. Chemical formulas show the numbers of each atom type that are involved in that compound. Sodium chloride is 1-to-1, but aluminum bromide is 1 aluminum to 3 bromine atoms. And so we use subscripts for those. So here is the arrangement of sodium chloride, and because it's a regular array that forms absolutely a cube, if you look at salt under a microscope, it actually looks like a little cube. No matter how small you grind it, it'll still be the form of a cube because that irregular array of positive and negative ions. So formula unit is the smallest whole number ratio of ions in an ionic compound. And so for sodium chloride, it's 1-to-1, but again, aluminum bromide is 1-to-3. And so that's how we know the ratio is based on those charges. So, use the electron dot structures to predict the formulas of the ionic compounds for the following compounds: potassium with oxygen and magnesium with nitrogen. I'm going to give you a little hint. Neither one of these is 1-to-1. So go ahead and pause the video here and try and write out your answers. And then I'm going to go ahead now to the answers. So first we have to know that how many electrons will be lost by the metal and how many electrons will be gained by the nonmetal. And we need to make sure it comes out to a 0 total charge. Since potassium has 1 dot and oxygen has space for 2 dots, we would need 2 potassiums for every 1 oxygen. And so we would get K2O. And this is what we're going to do after we know our ions. We're going to start naming compounds and making formulas. So magnesium has 2 electrons to give, but nitrogen needs 3. So it's not even going to be one of these two. It's actually going to be 3 magnesium to 2 nitrogen. And what you're really doing is you're going to the least common multiple of 2 and 3. And so it would be Mg3N2. And some of you may have learned to cross your charges. Since this is +2 and this is -3, we get a subscript of 2 for nitrogen and we get a subscript of 3 for magnesium. Electron dot structures can be used to determine the molecular formula of an ionic compound. And if you wanted to do that with calcium and fluorine, to get calcium fluoride, you would end up with 1 calcium for 2 fluorines, and you would have C2 or CF2. I'm going to stop here, and then we will continue on in the next video. See you in just a little bit.